Okay, well, let's have a look. What have we got to prove? We've got to prove that angle AOC, so let's write it down, AOC, so it's AOC, which is C2 there, AO2, or it's actually O2 rather, should I say. Let's rather put the 2 by the O there, so it's AO2 and C, and then we've also got the other one is triangle DO1 and B. Okay, look at that, D, O1 and B. Now we've got to prove that these angles are all equal. Okay, now let's start. Why would angle A be equal to angle D? Well, angles in the same segment. The arc BC is subtending equal angles there. And likewise, well, we could say C is equal to B, because that arc AD is subtending equal angles, or we could say angles in the same segment. Then, of course, obviously these two are equal via vertically opposite angles, but we can use that as the sum of the angles of a triangle, so it doesn't really matter. But let's have a look. So we can start here by saying in number A here, we can say, okay, in triangle AOC and triangle, what is that? Triangle AOC and triangle DOB. There we've got it. We've got our triangles. Let's check that. There we've got it. What do we know? The first thing we know in this practice example, that angle A is equal to angle D, and that, remember, is angles in the same segment, or you can use arc subtends equal angles, you see. So we know that angle A is D because arc BC subtends equal angles, or just angles in the same segment. And then the second one is angle C is equal to B. Once again, angles in the same segment of the circle. If you have a look there, C is equal to B. And then O1 is equal to O2. That's your third reason. O1 is equal to O2. That's because of, if you like, the sum of the angles of a triangle. So you could say sum of the angles of a triangle. I always use that reason, or simply vertically opposite angles being equal there. Okay, the vertically opposite angles, or just sum of the angles of a triangle. Okay, so therefore, triangle AOC is similar to triangle DOB. Reason, 3 pairs of equal angles. Okay, and there we've got it. Okay, so now the last piece is how do we prove that OB over OD? Let's write it down. So in number B here, you want to prove that OB over OD is equal to OC over OA. That's what this is what is required to prove. You must prove this. Okay, now how do we go about it? Well, let's go and do our frog face quickly. AO over DO, OC, OB, AC, DB. So let's write that down. Okay, so what do we know? If we write that down, we've got AO over DO is equal to OC over OB is equal to AC over DB. Okay, so that gives us from the frog face these ratios. Now let's see, what do we want in our proof? So I'm going to go to a different color here. We've got OB. Where's OB? Well, there's OB. OD is there, or DO is the same. Remember, OD and DO are pretty much the same. We've got an OC and an AOA there. So this is going to help us to get to that. Now, how do we do it? Well, not a problem. Well, let's just see. Let's make AO, make it OA over DO is OD is equal to OC over OB. So we've got the order right. OB is now, in rather AO becomes AO is OA, see. Okay, now how do we get that? Look at that. There's an O. If you take that, what we need to do is we need to get the OB on top of the OD. So what I'm going to do is I'm going to do the following. I'm going to do a little bit of algebra. If I multiply both sides by OB, I get OA over OD multiplied by OB is equal to OC. So you've kind of brought that on top there, and then what we can then also do is multiply both sides by OD. So OA times OB is OC times OD. Okay, this is where it gets a little bit tricky. Now, all we've got to do is we want to create that we want to bring that OD underneath there and bring the OA on this side. So what I'm going to do is, if I divide both sides nicely, if I do that, I can say if I divide both sides by OD, it will go underneath the OB, and if I divide both sides by AO, the OA goes underneath the OC. So we've got OB over OD is OC over OA. So all you have to do, think about this if you take OA, it just goes underneath on the other side, and OD goes underneath on the other side. So that's fairly tricky, but not too difficult to visualize if you think about it there. Okay, well that's it, guys. When you've got your similar triangles, it's pretty easy now to then get your frog face going, and you create your ratios here, which are these, and then you try and work it so that you can get back to that. Okay, so what I did is I extracted out this here and made it OA over OD, OC over OB, and then I multiplied everybody by OB, brought it up there, multiplied everyone by OD, it came up, and then I simply then brought if I've got OB, I bring the OD underneath, and I bring the OA underneath the OC, and there you've got it. Okay guys, stay with us, we'll get into some more interesting similar triangles in the next lesson.